mynews.studio.
Today is August 3rd, 2025. Picture a plastic that disappears at room temperature, yet is tougher than the stuff in your kitchen right now. Could this be the turning point for plastic pollution?
That's our focus today. Researchers at Washington University in St. Louis have developed something called LEAFF. It's a bioplastic that not only breaks down at room temperature, but is also stronger than many everyday plastics. Could you explain what actually sets LEAFF apart from traditional plastics?
Absolutely. The main innovation here is biomimicry. LEAFF takes cues from how leaves are structured in nature. It uses cellulose nanofibers layered between sheets of bioplastic. This design acts as a barrier to both air and water, which is ideal for food packaging. Plus, manufacturers can print directly onto it. That reduces steps in production, cuts down costs, and means less waste overall.
But just to clarify, why is breaking down at room temperature such a breakthrough? Haven't we seen compostable plastics before?
Great point. Most existing bioplastics actually need high temperatures, like those found in specialized industrial composting facilities. That's a real barrier, especially in places that don't have access to that infrastructure. LEAFF, on the other hand, degrades at room temperature, so it can break down almost anywhere. That could make a huge difference for regions lacking industrial composting options.
And in terms of strength, you're saying LEAFF is actually tougher than the common plastics like polyethylene and polypropylene?
Yes, that's correct. In lab tests, LEAFF outperformed those standard petroplastics in terms of tensile strength. It also resists humidity and air, both of which are crucial for keeping food fresh. And the ability to print directly onto the surface removes the need for extra labeling, which streamlines the whole production process.
It always comes back to plastic pollution. Billions of tons of plastic are still out there, breaking down into microplastics. Does LEAFF actually solve that at the source?
Yes, that's the key. LEAFF is made from renewable resources like cornstarch and cellulose, often coming from agricultural waste. So, it not only replaces petroleum-based plastics, but also turns materials that might be thrown away into something useful. And when it breaks down, it doesn't leave behind microplastics.
Let's talk about how soon this could be available. Are we close to seeing LEAFF in stores or in packaging worldwide?
That's going to depend on several things. The technology itself is ready, but scaling up will need investment in manufacturing and some changes to supply chains. The research team is actively looking for commercial partners. As for a timeline, it really hinges on how quickly the industry adopts it, regulatory approval, and whether consumers push for more sustainable options.
What about the potential for developing countries? Could they benefit from switching to something like LEAFF?
Yes, especially because LEAFF can be made from locally available renewable materials. That could bring down costs and lessen the need for imported fossil fuels. And since it doesn't require industrial composting, it's accessible even where waste management infrastructure is limited. So it could really open up sustainable packaging to more regions.
Which industries are most likely to pick this up first?
Food packaging is the most immediate fit. LEAFF's barrier properties and strength make it ideal for that. Single-use items like cutlery, plates, and wrappers are also likely candidates, especially in places with regulations favoring sustainable materials. As the technology evolves and costs fall, consumer goods and logistics could follow.
Are there any big hurdles that might slow down adoption?
The major ones are scaling up production and attracting investment. New manufacturing setups will be needed, and the supply chain has to adapt. Public awareness and industry support are also important. But in terms of the technical side, durability, affordability, compostability, LEAFF already has those covered.
How does the cost and energy use compare to regular plastics or other bioplastics?
LEAFF is designed to be competitive. It uses inexpensive, renewable sources like cornstarch and agricultural waste, which are widely available. The cellulose nanofibers come from existing waste streams, so material costs are kept down. And because it's printable, manufacturers can skip extra labeling steps. All of this helps keep costs and energy use low even without extra subsidies.
This feels like a step toward a circular economy, making materials from waste, then letting them safely re-enter the environment. Is that the idea?
That's exactly the vision. If we can produce packaging from agricultural waste, use it, and have it fully degrade without leaving pollution, we close the loop. The U.S. has an advantage because of its agriculture, but scaling up globally will need international cooperation.
To sum up, LEAFF is a bioplastic inspired by leaves, outperforms regular plastics, degrades at room temperature, and could help tackle plastic pollution, if enough partners help scale it up.
That's right. It's a practical solution with the potential for global impact, but the future depends on industry, policy, and what people demand. The real question is, will we make the switch?
Thanks for tuning in. Today we looked at LEAFF's promise, the hurdles ahead, and why this matters for people everywhere.
Thank you for listening. This episode was produced by mynews.studio. Try it out for free.